Welcome back everyone, Patrick here, and moving on to another question dealing with decomposition, very similar to the previous video, but in this case what we got to do, we got to find two values of C in each of these so that the expression can be factored. So notice in the previous video we had to find the B value. Well, in this case we're going to be finding the C value. So when I'm doing this video, I'm assuming you've watched the previous video because there's a lot of intricacies that I go through in that video with how to do a question like this overall, where you're solving for an unknown within the quadratic. So make sure you watch that video first before watching this one, because this one I'm going to go through a little bit quicker, and I'm assuming that you've watched that previous one. There's a lot of carryover. So if you're watching this on YouTube, you can go to the website where all of the videos are in order. There's a link in the description box. Okay, so if you have gone through that video, if you remember what happened in that previous video was we had to find two values of B, but then if you remember, there was times where we had like a plus bx in the middle, but then we'd have like a minus bx. And what I recommended was, instead of using a b value here, using a different variable, because it wasn't in line with that standard form quadratic. Okay, and when we're doing decomposition, when we're finding those two numbers that multiply to AC and add up to that B value, we're assuming this is the format that we are working with, right? So whenever we had a negative B, it wasn't in line with this positive B. And notice in this particular case, this positive C is in line with this positive C, so it's not as essential to change the variable here, but notice here we have a minus C. Notice here we have a plus 2C, minus 3C. Okay, so I mentioned this more so in the middle of the last video, but I'm going to mention it here in the beginning. If you get a question like this, I actually recommend taking this and putting a different variable. So you're not thinking that this C over here is necessarily this C that you're solving for, because if the expressions get more complex like this, right, then this C obviously is different than this one. Right, here we have a plus 2C, minus 3C. Here we just have a C by itself. This is different than this as well. We had a minus C, here's a positive C. This one's in line, which is nice, but that's not always going to happen. So I actually recommend, with a question like this, the textbook may not do this, they may give you something like this, but I would recommend changing the variable. So in this case, we'll use an M. So basically anywhere where there's a C over here, I'm going to put an M value. Right, so even if you get a question in your textbook with C values, unless it's plus C for all of them, I would actually recommend changing the variable so you're not getting confused with this C value over here. Right, and so now we're basically going to be finding the M values. So let's write out the first one. So we got x squared plus 8x plus m. So we know we're going to be using this like the previous video. So what's the a value? It's 1. The b value is 8. And then the c value is m. So what we got to do then is we got to multiply, right, because we need an AC value over here that we plug in. 1 times m is going to give us m. So in this case, because the a value is 1, the c and the AC are the same. That's not always going to happen. In the next section, the a value is not going to be 1, right? So then we'd end up with an actual expression here, which is actually going to make this question a lot more complex. But it's not bad in this case because we're basically just solving for this m over here. And then the b value we're actually given as a positive 8. So notice, compared to the previous video when we were solving for this middle term, it's basically switched now. Before we were given a value, we had a value, a number here, and then we had to find two numbers that multiply to that, and then we would find the b value. Well, now all we have to do is we got to find two numbers that add up to this 8, and then we just multiply those two numbers to get the m value, right? So the two numbers that we're going to pick is going to come from this line. Before it was coming from this line, now it's coming from this line. So as you can see, an infinite amount of possibilities here, right? So let's pick maybe, I don't know, 6 and 2, right? 6 plus 2 would give us 8. Well, what's 6 times 2 going to be? That's going to give us 12. So that, an m value of 12, let me split this up over here. So an m value of 12 works, right? Because we would be using the same numbers here. And then just to confirm that it works, what you can do for all these questions is take your value, plug it into the expression you're given, get the quadratic, and just make sure that that quadratic factors. And if you do the decomposition on this, the two numbers were 6 and 2. We could take out an x. We could take out a 2. And then we could take out this bracket. And we end up with that. So if the m value is 12, in this case, that's what it's going to factor to, right? So that's one combination. What's another combination over here? What else adds up to 8? So let's say 5 and 3, right? 5 plus 3 gives us 8. What's 5 times 3? That gives us 15. So an m value of 15, sorry, let's actually leave that and put that here. An m value of 15 works as well. And if you were to do the whole decomposition process, if you factor this, it would give you x plus 3 times x plus 5. Right? So if the m value is 15, the expression is also going to factor into those two values. Right? So you just got to make sure that this works out here. Now, we just have to find two values, but let's find a couple of more. Now, another thing that could work, because we have a positive 8 over here, notice that we can actually have a combination of positive and negative values that we plug in here. So for example, like 10 and negative 2 works, right? 10 plus negative 2, which is like 10 minus 2, would give us 8. So then what's 10 times negative 2? That would give us negative 20. So putting a minus 20 for m, this would turn into minus 20 over here. So this works as well. That's another potential combination. Okay, and if you take this and you factor it with decomposition, as we've been doing many times in previous videos, what you would end up with is x plus 10, x minus 2, right? Because the a value is 1, it's just going to be those two values. But again, that a value is not always going to be 1, as you'll see in future videos, right? So an m value of negative 20 also works, right? So an infinite amount of combinations here. You could also maybe do like, let's say, positive 30, negative 22, right? So this would be positive 30, negative 22, and that would give us what? Negative 660, right? 30 times negative 22 gives us negative 660. So that's another m value that would work. If this was negative 660, this here would factor into x plus 30, x minus 22. Okay, so that's another combination that works. So really just an infinite amount of combinations, as long as you find two numbers that make this work out, you just take those two numbers, put them here, and then you get your m value. Because it's a positive m, you get that m value directly, right away, right? But that's not always going to happen with these. You're going to see that, let's say over here, we're going to have like negative m, then you're going to have to solve this. Over here, you're going to have to go like negative m equals negative 660, divide both sides by -1, etc., etc. But because it's a positive m here, you're getting that m value directly at this step. All right, so there's a few combinations that work out. And again, whatever combinations you use or whatever values you get for m, plug it in to the expression. Make sure that it factors so you could be fully confident. Another thing I actually want to mention is maybe sometimes your teacher or maybe the test will say you need to give an m value or a positive m value, so then you wouldn't put -20, you would just put 12 and 15, right? It's usually not going to say that. The reason why I want to mention that is because with questions like this, usually the answers in the back are going to be positive in a textbook, but they don't necessarily always have to be, like we just saw over here. They could also be negative values. As long as it works out, then you're all good. Okay, now let's move on to the next one. So we got x squared minus x minus m. Okay, so in this case, the a value is 1, the b value is -1, and then the c value is -m, right? It's this entire thing over here, right? If we rewrite that standard form, this -m is equal to this positive c, right? The b value is -1, the a value is +1. So we have to then take the AC value, which is -m. So what do we do then? We're finding two numbers that multiply to that AC value, which is -m, and adding up to that b value of -1. Now, because the variable we're solving for is here, the two numbers that we're going to pick, we have to find them over here in this line, because we know that the two numbers, when we net the two numbers out, when we add them out, they have to equal, the sum of them has to equal -1. So what are two numbers that would work out? Let's say like -3 and +2 work out, right? -3 plus 2 gives us -1. So you just take those two numbers, put them up here. -3 plus -3 times +2, right? Yes. What's -3 times +2? That would give us -6. Now, because we have a -m here, right, we got to do the algebra on this equation on the side. So here we would divide by -1. M would be +6. So that is an m value that works out. We had to do this algebra here because it wasn't just +m over here. So that wasn't the direct answer, because they want the m value. They don't want the -m value, right? So to get the m by itself, we have to divide both sides by -1 to get the m by itself. So an m value of 6 works. And if we take that m value of 6, if we plug it in here, we'll have x squared minus x minus 6, right? Minus +6 is just -6 right there. If you do the decomposition of that, if you want to check your answer, it would end up being x minus 3, x plus 2. That's what it would factor to, right? So an m value of 6 works. What's another combination here? Actually, I should have just erased these. So we got -m for the AC, and then the b value is -1. Okay, so what else is going to work? -20, +19. Right? If we use bigger numbers, you could put -5, +4. You could put -6, +5. Just an infinite amount of answers over here. Okay, but if we use -20 and +19, -20, +19, Negative 20 times positive 19 would give us what? It would give us negative 380, right? But the negative m has to equal the negative 380, which means m equaling positive 380 would work as well, right? So that's another combination that that would work as well. Just give me a sec here. Yes, right? This is positive 380. This would be 380. And then that would factor, if you do the factoring, the two numbers would be x minus 20, x plus 19, which was basically these two numbers. That worked out only because the a value is positive 1. That's not always going to work out, as I mentioned countless times before. Right, so that's how you do that type of question. And so again, once you have an expression here that's not just a positive m value or a positive c value as we had before, it's not too big of a deal. You just got to do this extra algebra at the end, right? And so the same process is actually going to apply for part C. So if we rewrite all of this, let's erase this. So we got x squared minus 4x plus 2m. Let's actually rewrite that standard form just for reference. Okay, we got to get all these values. So the a value is 1, the b value is negative 4, the c value in this case is positive 2m, like that. What's the ac value going to be? 2m times 1. It's just going to be 2m. Okay, again, not always going to happen where it's equal to the c value, but because the a value is 1, it does equal the c value. So in this particular case, we got to find two values that multiply to 2m and add up to the b value of negative 4. So this one, I feel like it's not even more complex than part B. It's just whatever value we get here, we got to do that algebra at the end. 2m equals whatever those two numbers are going to multiply to. The two numbers we'll get from here. So what combination of numbers add up to negative 4? Negative 6 and 2 work, right? Negative 6 plus 2 gives us negative 4. Taking those numbers, putting them up here, negative 6 times 2 would give us negative 12, right? That's the AC value, but that's not what we're solving for. We're solving for the m value, so we got to take this equation and then do this on the side, right? Divide both sides by 2. So you'd end up with m equaling negative 6. So an m value of negative 6 works. Now, if you want to check your answer, you would take that m value, negative 6, plug it in there. You'd end up with x squared minus 4x. 2 times negative 6 would give us negative 12, as expected, our AC value from multiplying these two. And if you do the decomposition on that, it would factor into x minus 6, x plus 2. Right? So an m value of negative 6, if we plug it in here, it works. So notice in this case, we have a more complex expression for that entire c value, but it's still not a big deal. It's just that algebra at the end. There's a little bit more to it. Right? So yeah, that works out. Now, if you have something like this, you can also actually end up getting like fractions, I think, for this. So for example, if we use like, let me think here. Again, there's an infinite amount of solutions here. So let's say we do like negative 5 and positive 1. Right? Negative 5 plus 1 gives us negative 4. If we plug in negative 5 and positive 1 here, negative 5 times positive 1 would give us negative 5. So then when does 2m equal negative 5? That's going to happen when m is negative 5 over 2. So notice here we could get a fraction as well. That's a combination that works. And if we take this fraction, plug it in here, watch what happens. X squared minus 4x plus 2 times negative 5 over 2. The 2's cancel out, or negative 5 over 2, which is like negative 2.5 times 2 would give us negative 5. So we'd end up with negative 4x minus 5, which is what we wanted, right? So you just got to figure out what you got to plug in for this m to get this value, to get that AC value of negative 5 over here. Okay, and if you factor this, it would end up factoring into x minus 5x plus 1. So an m value negative 5 over 2 works as well. Okay, let's try another one. One more. Actually, I'm not going to erase this. I got to erase this. Okay, so what else works over here? Let's do, I don't know, negative 12, positive 8. Right, negative 12 plus 8 gives us negative 4. So if we plug in negative 12, positive 8 over here, we'd end up with negative 96. Right, so a C value, or sorry, an AC value of negative 96 works, but because we're dealing with an A value of 1, that's also just going to be the C value. Right, so this works over here. So basically, when does 2m equal negative 96? That's going to happen when m is negative 48, if we divide both sides by 2. And then, as usual, checking your answer, you could take that negative 48, plug it in. You'd end up with x squared minus 4x minus 2 times negative 48 gives us that negative 96. Okay, and that's going to factor into x minus 12, x plus 8. Okay, so an m value of negative 48, if we plug it into this expression, it makes the expression factorable. It factors into that right there. Okay, so an m value of negative 48 works too. Right, and then finally the last one. Let me think about what to erase here. I think like that. So we got x squared plus 5x minus 3m. So same process. A value 1, B value positive 5. The C value is negative 3m. What's the AC value? Negative 3m times 1 is negative 3m, like that. So we got to find two numbers that are multiplying to negative 3m and adding up to positive 5. Okay, so you could pick anything. Let's actually try to pick two numbers where when we multiply them, they're going to have a factor of 3. So then that m value we get is an integer. It doesn't necessarily have to be an integer. It doesn't say that it has to be, but let's say it's said that it has to be an integer. Well, you could pick 8 and negative 3, for example, right? 8 plus negative 3 would be like 8 minus 3, which would give us positive 5. So using those two numbers up here, 8 times negative 3 would give us negative 24. So negative 3m equaling negative 24. Divide both sides by negative 3. M would be positive 8. Right? So m equaling positive 8 works. And again, if you want to check your answer, you could take this, plug it in. If we plug in positive 8 over here, we'd end up with minus 24. That would factor into x plus 8, x minus 3, like that. Right? It's also just a coincidence that this m value and then this 8 are the same. So an m value of 8 works, right? What else could work here? So let's try a few more numbers. Let's say 11 and negative 6. Right? 11 plus negative 6 is like 11 minus 6. So 11 times negative 6 would give us negative 66 over here. So when does negative 3m equal negative 66? Well, that's going to happen when m is what? Positive 22. So an m value of positive 22 works as well. And if we take that, check it, plug it in here, we'd have minus 66 like that, which would factor into x plus 11, x minus 6, if you do the full decomposition process, right? So an m value of 22 works as well. And again, it doesn't necessarily have to be integer, so maybe if we did like, let's say 6 minus 1, like that. What if it was 6 minus 1 up here? 6 plus negative 1, 6 minus 1 is positive 5. 6 times negative 1 would give us negative 6. Oh no, that would give us an integer as well. Sorry, let's do 7 and negative 2. I think that would work, right? Because we'll get negative 14 there. Yeah. 7, negative 2, negative 14. And so when does negative 3m equal negative 14? That's going to happen when m is positive 14 over 3. So that's another combination where that m value we solve for is not necessarily an integer. Right, so that works. If we take 14 over 3, plug it in here, because we're dealing with fractions, just be a little bit more careful. Right, notice the 3's would cancel out, so we'd have x squared plus 5x minus 14, which would factor into x plus 7x minus 2. Right, so if m is 14 over 3, we would get a quadratic that factors into those two. Okay, so that's the process for these kinds of questions. So whether you're solving for a potential variable within the b value here or within the c value like we did with all these videos or with all these questions, process is the same. It's basically you want to get to here and then just find those two numbers, and then once you find those two numbers, it's not too bad.